All right, guys, let's try and finish this assignment. I'm getting really bored of it. I don't know about you guys. So I'm on 10. This isn't a multiple choice. This is an AP College Board free response question. This is what free response might look like on the AP exam. So we have the function f, it's a piecewise function. And for a, for what value of k, if any, is f continuous at x equals -3? So we've done these problems before. I'm going to set these two parts equal to each other and plug in -3. However, I am looking at this expression right here, and it does look like it's factorable. So I'm going to factor that first. 2x, and then that will be x over, that's going to become x plus 3 and x plus 1. And so because I have a feeling that one of these is going to cancel, I have a feeling that this is going to be plus 3 right here. And then, let's see, this right here is going to be 6x. So that means this has to be minus x in order to get that positive 5x. So it's going to be -1. Yep, that sounds right. So when I multiply those together, I get the 2x squared. When I multiply those, I get 6x, but when I multiply these, I get 1x, -1x. When I add them together, I get positive 5x. Then I multiply those together, I get -3. Perfect. So I was right. Those cancel right here. So I get the expression of 2x minus 1 over x plus 1. And then, so for part A, I'm going to take the 2x minus 1 over x plus 1, set it equal to kx plus 1/2, this part right here, and I'm going to plug in -3. So 2 times by -3 minus 1 over -3 plus 1 equal to k times by -3 plus 1/2. So that becomes -6 minus 1, so that becomes -7 over -2 equal to -3k plus 1/2. I subtract the 1/2 over here, so that's just going to be positive 7/2. And then if I subtract 1/2, that's going to become 6/2, which is going to become 3, I think. So that's going to become 3. Okay, so that becomes 3. That's going to be equal to -3k divided by -1. So k is going to be equal to -1. Okay, so for what value k, if any, is f continuous at x equals -3, that's if this value is -1. For B, what type of discontinuity does f have at x equals 0? Okay, at x equals 0, well, let's see here. If I plug in 0 here, I get 1/2. So I know that the limit as x approaches 0 from the left of f of x, that's going to be equal to 1/2. The limit as x approaches 0 from the right of f of x is going to be equal to, so if I plug in 0 here, I'm going to get 2 to the 0 over 3 to the 0 minus 1. So then I get 2 to the 0 over 1 minus 1. So I get 1 over 0. That's definitely going to be an asymptote. So I'm going to go with that. We have a vertical asymptote right there. Yeah. For C, for all horizontal asymptotes of the graph of f, find them all. Okay, so I only need to check here and here. So what's going to happen? We'll say this right here. So the limit as x approaches negative infinity of f of x is going to be equal to the limit as x approaches negative infinity of 2x squared plus 5x. I'm not going to worry about that. It's going to be equal to 2x squared over x squared. Again, at very large, if I'm thinking about a rational expression, these are not going to matter at positive or negative infinity. So then I just have to look at the leading term, the terms with the highest degrees, and then those are eventually going to cancel, leaving me with 2. Okay. All right, and then let's do the limit as x approaches positive infinity of f of x. So then I'm going to look here. So let's think about, I'm not going to worry about this at infinity because that's not going to matter. So let's think about 2 to the third over, 2 to the x. So limit as x approaches infinity, 2 to the x over 3 to the x. 3 to the x is going to grow a lot larger because it has a larger base, and so that means it's going to be equal to 0. So we have at y equals 2 and at y equals 0, that's where we're going to have horizontal asymptotes. Okay. All right, for 11, the total accumulated revenue of a company has received up to time t is modeled by the function r defined here, where r of t is measured in millions of United States dollars and t is the time in years since 1980. So find the limit as t approaches infinity of r of t and explain what this means. So at infinity, I'm going to evaluate this piece of it. So the limit as t approaches infinity of r of t, I'm just going to say is equal to the limit as t approaches infinity of 100t squared plus 1000 over t squared plus 600. And that's going to be equal to the limit as t approaches infinity of 100t squared over t squared, because these are going to be negligible at infinity. And then these will also be negligible at infinity, leaving me with 100. So this is going to be equal to 100. So what is the interpretation of that? So as time increases, what is t? Is t, yeah, years. As time increases in years, the revenue, because that's what r of t, the revenue will approach $100 million, US dollars, I guess. So that's the interpretation of what that actually means. For b, is the function continuous at t equals 20. So for that part, let's do the limit as t approaches 20 from the left side of r of t. And that's going to be equal to the limit as t approaches 20 of 41 square root of t over 20, which is going to be equal to 41 times by the square root of 1. So that's just going to be equal to 41. Let's do the limit as t approaches 20 from the right of r of t. And that's going to be equal to, we're just going to plug in 20 over here. So it's going to be equal to 100 times by 20 squared plus 1000 over 20 squared plus 600. And you can definitely use a calculator for that, I'll say. Let's see, so we got 100, 20 squared, that's going to just be 400, right? Plus 1000 over 40 plus, okay, I'm bad at this. I'm going to use a calculator. Let's see what we get. All right, so what did we say we have? 100 times by 20 squared. Was it plus 1,000 or something? Divided by 20 squared plus 600. And you get 41. Whoops. And you get 41. So yes, it's continuous. As far as the justification, I would say that the limit as t approaches 20 is equal to r of 20, which is equal to 41. It does equal, right? So, yeah. So it is equal to 20 here. Either way, it's going to be 40. So, yep, 41. And then for C, what the heck? The company's total accumulated expenses up to time t is modeled by this function E, where E at t is measured in the millions of US dollars. So this is expenses. According to those models, is there a time t from 0 to 5 at which the total accumulated profit R of t minus E of t is equal to 0? Okay, so here's what we're going to do. So, profit. I'm going to say P of t is equal to profit. So our profit is equal to our revenue minus our expenses. And I'm going to find P of 0. So if I find P of 0, I have to take R of 0. R of 0 is going to be 41. And now I need to find E of 0. E of 0, so if I plug in 0 here, oh my gosh, gonna have to do some algebra. So 3 log base 2. If I plug in 0 right here, I'm gonna get 4. And if you guys remember how to evaluate logs, great, because I'm struggling right now. All right, I got it. So 3 log base 2 of 2 squared. And then with logs, if they have the same base, right, if those are the same, then they cancel. So then that becomes equal to 6. I hope I'm right there. Let's hope. So minus 6, okay? So keep that in mind. Yeah, so that's gonna be equal to 35, right? Hold up. Plug in 0 here. That's not plus or minus, that's times. So this whole thing becomes 0. That becomes 0. Not 41. So this becomes equal to negative 6. So their total profit is negative $6 million in the first year. But after 5 years, so let's do P of 5, that's going to be equal to R of 5 minus E of 5. So let's see what R of 5 is. R of 5 is going to be equal to 41 times by the square root of 5 over 20. 5 over 20 is 1/4, right? So that's going to be equal to 41 over 2, which is going to be equal to 20.5. Now I need to find E of 5. So E of 5 is going to be 3 log base 2 log. That's going to be equal to 64. because 5 times 12 is 60, so plus 4. Okay, let's think. We gotta think in terms of exponentials. 2 to what power is 64? I know 4 to the third is equal to 64, and 4 is equal to 2 squared, so that's going to be equal to 2 to the 6th, so that's going to be equal to 3 log base 2 of 2 to the 6th, so that's going to be equal to 3 times by 6, which is going to be equal to 18, so minus 18. So, and that's going to come out to be equal to 2.5. So what are we trying to get at right here? So according to these models, is there a time t? Is there some time in the first 5 years that the total accumulated profit is equal to 0? So one thing that we need to know is that we need to check continuity. Does it specify continuity? Is the function r continuous at 20? Yes. This function is continuous between 0 and 20. This function is continuous for t is greater than 20. I think that's all we need. Oh yeah, we don't need 20. So are we continuous between 0 and 5? Yeah, this is a continuous function between 0 and 5. And so because it's continuous between 0 and 5, it has to take on every y value between -6 and 2.5. So yes, r of t is continuous on 0 to 5. So by IVT, I'm just going to leave it right there. So yes, by the intermediate value theorem. So I think I'm going to call it there. All right, what a homework assignment. Hopefully this helps.